Okay, so we're gonna talk about waves. And in the context of this, we're gonna be talking about this for the next couple of weeks. We're gonna be talking about what waves are, parts of a wave. We're gonna look at a wave equation, that's a little bit of math. We'll look at properties of waves, sound as a wave. We'll look at sound as mechanical waves, and we'll look at properties of sound waves. And we'll also talk about the Doppler effect. Okay, but first we're gonna start off with what are waves? We need to know what they are, right? Does that make sense? Okay, Terry, are you there?
Almost. I just need to get on the tent.
Okay. Okay, now on your copy, you're not gonna see this, animated GIF here. But a wave is a disturbance that travels through space or matter. So what do you notice about the movement of this water here? It's actually waving, right? It's waving. It's waving, right? Waving. Okay, it's actually waving. So that's where they get the word wave from. Okay. Okay, so what causes a wave to form? What causes a wave to form?
My Chromebook turned off.
What's the matter?
My Chromebook turned off.
Okay, I would start it back up. So look right here. So what causes a wave to form? You see this picture right here. This is not animated. This is just a picture. Do you see any waves in this?
No.
No.
Well, if you look really, really, really super close, it looks like it's still, right? So when it's undisturbed, the water is found in its equilibrium or rest position. Okay, so it's at rest right now, right? It's at rest, pretty much at rest. And at rest position means equilibrium, and the word equilibrium, you see that word? Not good in the video. Okay. Okay, so when undisturbed water is found in its equilibrium, and equilibrium is a term you see quite often in science, and it basically means equal. It also means at rest, not doing anything. Okay. Okay. So again, what causes a wave to form? Well, all waves start by disturbance in the space or matter they travel through. And the wave starts when the water particles are disturbed and move away from the rest of the position. Look here, here's a place right here. Somebody threw a rock in there, it looks like, or maybe, or even sometimes a big drop of rain on a lake will cause waves to form. Wind sometimes. So the wave starts when the water particles are disturbed and moved away from the rest position, and they want to bounce back. Okay, look here, how they're bouncing back.
Mm-hmm.
They go to out, then they boom, out, and so on, right? So the disturbance moves outwards in all directions, 360 degrees, right? Okay, so let's look at pulses versus a wave. Okay, so a pulse is a single disturbance that moves outward. You just stick your finger in the water and you're gonna, or even, you can do this even in a sink of water. You can do this in a sink of water even. Just put your finger in there and the waves are gonna start to spread out, right? And then they're gonna stop. It's gonna go back to its equilibrium position or rest, right?
Mm-hmm.
Okay, however, a wave itself is a series of pulses that produces repeating and periodic disturbances in the medium. And normally I would show you a video because I'm recording this and because of and I got students at home that are watching this. I will show this video to you later. For those of you at home, I'll try to find a video and put it in a link so that you can watch this video, but I can't show it to you and then upload the video itself to YouTube. There's copyright laws in effect. Anyway, suffice it to say that we'll look at this later, and and for the virtual students, I'll send you something about, video on pulses and waves, okay? Okay, so let's look here. The wave medium. What's a medium? Well, mechanical waves are waves that travel through matter. Okay, mechanical waves are waves that travel through matter. Mechanical waves are what water are mechanical waves. That means they're motion, right? Moving. Okay, mechanical waves are waves that travel through matter, and a type of matter the wave travels through is called a medium. Okay, and that medium can be either solid, liquid, or gas. So what's this right here in the water? Liquid, right? It's going through liquid. You know, sound. If someone were to pull up a trailer and they had a rock band or something on it, or a rap group on it, and they started playing music, could we hear them from outside? Oh, yes, we could. And guess how we would hear them? Waves, sound waves, would come literally through the door, through the blocks, through the roof. Yes. So you would hear them. So sound waves themselves can come through solid material. Okay. Okay. So a medium can either be solid, liquid, or gas. So what medium is this wave traveling through right now? It's what?
Water.
Liquid, right?
Liquid.
Yeah, liquid. Water, which is liquid. Yeah, you're exactly right. Good. Okay. Okay, so making waves. Okay, so this is another thing here that PHET. Actually, if you look at on Mr. Hughes' Google Classroom in your spare time, I actually put the link to PHET. It's a site that has different simulations, science lab simulations. You can actually go in there and do a wave simulation again that goes back to, if I were to upload this video for my virtual students, copyright laws, YouTube wouldn't let me upload it. So I'm not going to go in there right now. You can go to Google Classroom on your own time, not now. And there's a PHET link. PHET, it's a website. And they have different science simulations, okay? Okay, so, and we're going to pass number 2 up right off the bat. Okay, so let's look at number 2 right here. You're going to answer this. You're going to answer this in on your copy. At home, you're going to answer this on your copy. And then whenever I tell you to in this video, you will submit it. Right now, we're not going to submit it today. We're going to add questions to this, and then you submit it. I'll grade it, and then I'll send it back to you, and then you unsubmit it. Okay, and then we'll do the next set of questions, and so on. And if you have questions about that, email Mr. Hughes or call me. Okay. Okay. So let's look right here at this question right here. You're going to give me an answer, right? So a pulse is a single disturbance that travels through a medium. Is that a true or statement or a false statement? Mark your answer. Everybody got an answer? Michael Carnell, you got an answer for number 2. Don't worry about number 1. We didn't do the simulation, so we're not going to answer the question. Everybody got an answer, true or false? I'm going to move on here now. Okay, look right here. Which is the best way to start a wave and keep it going? Forget about in the simulation. Mark B and move on.
D.
B.
C.
B. As in
B.
boy, yes. Select oscillation. Oscillation is a term where it's a continuous movement, okay? Continuous. Oscillate means you continually move something, okay? You'd have to look at the simulation to get that answer. Okay, so based on the simulation, which of the following would be the best definition of the word oscillate? It's either to move or travel back and forth, or to move or travel in one abrupt motion. A or D. Mark your answer. Can't choose B or C. B or C. I mean, B or D, I'm sorry. I mean, A or, let's see, let me do this again, A or D. You know, we just changed our clocks, what, back? And it got my bio clock off, so,
So we still get at 255?
huh?
So we still get out at 255?
Yes. Mhm. Okay, I'm gonna move on now. Okay, so how, let's look right here, if you were in simulation here. How would you describe the movement in the green, of the green bees? What are they doing here? As, Michael Carnell, can you, shut that door right there? Please. Okay, we're gonna skip this question, move on. Okay, let's look right here. Let's look right here. Are you here? Okay, so waves transfer energy and not matter, okay? So, in other words, when you've got, when you have a wave coming towards you in the ocean, or on a lake even, on a lake, or even in your, if you have an outdoor swimming pool, even, you know, like one of those little blow-up swimming pools, even if you got one of those and you get waves started in there, it's not the actual water moving, it's the energy moving through the water. Okay, so it's not the actual water moving, it's the waves move, it's the energy moving through the water. So as energy moves through a medium in the form of a wave, the particles in the medium vibrate around the rest position. So the water's just vibrating and the energy's moving through it. The water itself is not moving individually, okay? The water itself is just vibrating. So is the medium moving across or up and down? What's it doing? It is, it's going up and down, right? Okay. Okay, so, let's look right here. Oh, and by the way, that is a,
Energy, DNA. It's like a DNA kind of like.
huh?
The way it's moving.
They're vibrating up and down, right? Okay, okay, so look right here. This is what's called a transverse wave, and this wave is classified as a transverse wave, and particles in a transverse wave vibrate at right angles to the direction of the energy movement, okay? So the energy moves right to left, from right to left, right? And the particles move up and down. Okay? Got the idea? Remember this, what's a transverse wave? Particles vibrate at right angles to the direction of the energy movement. Okay? Right angle, you know what a right angle is, right? Right in the center here, you got a right angle. Right up in here, you got a right angle, right? Okay. Okay, so here's our question here. A substance,
We didn't answer number 5.
we didn't.
Oh, yeah,
We're
yeah.
gonna answer number 6 though. A substance that a mechanical wave moves through is called a what? A vacuum or a medium? A substance that a mechanical wave moves through is called a what? A vacuum or a medium? Can't choose C or D. Vacuum or a medium? Mark your answer. Everybody got an answer? That should be an easy one. If you miss that one, I'm gonna be disappointed.
Wait, can you say that again?
The substance that a mechanical wave moves through is called a what? Is it called a vacuum or is it called a medium?
A or B?
A or B? Yes. Okay, let's go to the next one. All right. Okay, look at number 7 here. Okay, the resulting position of a medium when there is no wave passing through it is known as what? That's when it's at rest. That's another word for rest. Is it called the minimum displacement or is it called the equilibrium position? C or D? One of those terms I talked about, the other term I didn't talk about, so there's a hint. The resting position of a medium when there's no wave passing through is known as what? Is it known as the minimum displacement or the equilibrium position? That should be an easy one. Okay, everybody got an answer?
Mm-hmm.
Okay. Let's look at number 8. Let's look at number 8. Which of the following is the example of a wave medium? Air molecules and other gases, water, a slinky, or all the above? Okay, okay, so normally I wouldn't give you the answer right now, but I want to talk about this, because we haven't talked about a slinky, and we haven't talked about air molecules, but let's just reason this out here. What do you say?
I always pick all of the above when it's an
Okay,
answer
so
choice.
that is a test-taking strategy. If you see an all of the above, and you know what a slinky does, right?
Yeah, if like.
Yeah, so, okay, so there's 2 right there, so we talked about water. Does air do the same thing? Yes, sound, right, sound waves. So what's your answer? For you at home, also. There's your hint, okay? I'm gonna move on here. Okay, the particles, remember this, we just read this sentence here. The particles in a transverse wave vibrate at right angles to the direction of the wave motion. Is that a true statement or a false statement? We just talked about that. I think I read that like 5 times earlier. The particles in a transverse wave vibrate at a right angle to the direction of the waves. Remember those waves are going that way? Okay, I'm gonna move on here. Okay, look right here. Waves transfer what? Do they transfer matter, energy, or energy and matter? Can't choose D. Waves transfer what? Matter, energy, or energy and matter? We just talked about that. If you were in a pool or something, is the matter moving, or is it just the energy moving? There's your real big picture, or is it both? Mark your answer. Okay, I hope you got that one right. Okay,
It
now,
couldn't be
for
D,
you at
could it?
home, you don't have to guess. Go back and look at. You can go back and look at the slides. You don't have to guess. Just go back and look at the slides, and it'll give you an answer.
It couldn't be D, could it?
Can't be D. Nope. Nope, can't be D. Okay. I'm gonna move on here.
That was the last one.
Okay, so I think we're going to stop right here. And we'll talk about parts of a wave in the next video.